so as to be able to access the voltmeter alone, okay? And here's what I did. I took the 6.3 volts AC and I passed it through a selector switch, which is this switch here, this selector switch. And then I activated I left it unconnected, not non-connected, in the RF position, so the generator can be used only as a generator and monitored by the internal vacuum tube voltmeter. And then in the vacuum in the voltmeter position, I energize a relay which changes the state of two switches. It's a dual pole, dual throat relay, and the original positions of the relay are soldered directly to these terminals. So I think it might be easier to explain the original positions using the schematic, the original schematic. So here we are in the schematic, and basically what I'm doing is I cut this line here from the V50 pin number 2, which is the grid. So I cut the grid here, and I also cut this line here, okay, directly at the R51, if I read correctly now from the schematic. Yeah, the R51, the meter zero adjust potentiometer. Be warned that you don't have to cut this line directly at the pin, because you will disconnect the meter, okay? The meter must be always connected to number 3, which is the cathode of this section of the tube, but we have to cut the line here. And basically what I'm doing with this dual pole, dual throat switch here, the relay, is I select this position, connecting grid number 2 to the wiper of this meter calibrate potentiometer, and actually connecting pin number 3 and the meter to the meter zero adjust potentiometer. So when I'm in RF position, the circuit, the schematic, is exactly like this. However, when I switch to the vacuum tube voltmeter position, I switch to a different set of meter zero adjust resistor and potentiometer, and a different set of meter calibrate potentiometer and resistor. And the reason that I'm doing this is that I don't want first to decalibrate the meter, the vacuum tube voltmeter, when I switch to the voltmeter position. I want this meter to be ready calibrated when I switch back to the RF position without having to touch the internal controls. And the second reason is that I'm going to use an external probe at this point. And when I use this external probe, this probe will output a different output voltage. When the RF voltage is detected, it will output a different output voltage than the internal detector of the instrument. So this has to be separately calibrated. So I have to have a separate set of meter calibrate and meter zero adjust components, and calibrate this probe directly under this second set, which is this set, the meter zero and the meter calibrate. When it is calibrated, the probe will measure directly and correctly the right voltage, and this voltage will be displayed in this meter here. And when I switch back to the RF generator mode, the same voltage, the appropriate voltage, will be again read in this meter here, without the need to readjust the controls. So with a single flip of a switch, I can directly measure either the the voltage of the output voltage of the oscillator or the detected voltage out of the calibrated probe. So that's the reason for the separate calibration here. And honestly, I could really get away with the relay, and this is a 6 volts AC relay, okay? It's not a very common relay, it's a 6 volts AC relay to get the power directly from the heater of this tube. And I could really get away with this relay and just use a dual pole, dual throat switch instead of this switch here. The reason that I thought it would be a little bit of better to use a relay was the physical position of the elements around this voltmeter and the front panel. So I thought it would be better for the components to be closer to this tube here. Honestly, this is not very necessary since this is a DC anyway voltmeter, but thought it would be a little bit of a better idea. The final reason, due to the different physical position of these components, is that by using a relay, I can only use just 3 cables. The ground is common, so I can use just 3 cables that pass from this side of the chassis to the other side of the chassis through the holes down there. So that's the reason that I use the remote relay. And you have already seen the head here, okay? And here is our switch. Here I use the dual pole, dual throat switch, but only one section is used, and 3 cables that are passing down here, coming in the other side of the chassis, okay? And here's what I did to mechanically support the relay and the potentiometer, the meter calibrate potentiometer. I've used a single piece of U-shaped aluminum. I'm not going too close in there because the instrument is enabled now, is switched on. So I have used a U-shaped chassis here, and I mounted the potentiometer and the relay like this. And on the other side, here's the vacuum tube, the vacuum tube voltmeter tube, right? And you see how close the connections are. I have just used these 2 wires here and a few other pieces of wires to connect it to the tube. In the RF position, okay, and then I've used the longer cables, of course, to connect it to the tube in the voltmeter and the external in the voltmeter position, okay. And one thing you have to notice is this meter cable that was originally going to the meter. You have to disconnect in there. It's difficult to see that, but you have to disconnect the cable from in there and connect a different cable that goes right there and directly to the meter, okay, here. Because the way they have connected it, the original cable was they have connected a cable into the meter, and then from the meter they connected in the meter 0 adjust, and then they connected another cable from the meter 0 adjusted to the now a final thing to notice here is that this voltmeter input is a DC volts input, but it's a negative voltmeter input, okay? The way the internal detector of this instrument has been implemented was to output a negative voltage, and you cannot use positive probes. Have a really nice probe here, but I cannot use it because this is a positive probe, okay? So it outputs a positive voltage, and actually when you try to measure this in the voltmeter, the meter will go downwards, not upwards, okay? So take care that you cannot use it as a general purpose voltmeter here, DC voltmeter. You have to use an RF probe, and the purpose is actually not to use it as a general purpose voltmeter, vacuum tube voltmeter, but as a detector, with a detector probe as an RF voltmeter, okay? And the detector probe has to be a negative probe, not a positive. So let's try to make this thing, to see how this thing is working. Now I'm in the RF position.